Hey everyone, welcome. This is Jason Clemmons, Doctor of Chiropractic at the Rock Health and Wellness Center, and this is Life with Jason Clemmons, DC. We are live right here at the Rock Health and Wellness Center studios in Lubbock, Texas, and coming to you live on Facebook, X, and YouTube at our different channels, and we're live on 98.7 Walk by Faith Radio and 1420 AM Lubbock Christian Nation. You can stream us if you would like to on 987radio.com, or you can get us on your app, the Live 365 app on your phone, and listen to the radio if you would like to do that as well. We've had a good week. We've been trying to get down to some serious business this week and really talk about some things that might make our lives better. And I really do appreciate all the feedback that we've gotten with these three shows that we've done this week. We took health to church on Monday, and I tell you that's a massive one. If you haven't seen it, you should go back and listen to that. It's a teaching of Matthew 13, verse 44 through 46, and I don't think there. I don't know if there's a more important scripture in the entire Bible related to our health than Matthew 13, verse 44 through 46. When you find your treasure, you will sell everything you have, and you will go and buy the field that your treasure is in. And it's all about your why. It's all about your value. Had that conversation today with one of my couples and their daughter, and we're waiting to get their daughter in here in the office. And he said the reason that she hadn't come in is because of money. And I said, nope, the reason that she hasn't come in is because of value. She hasn't found the treasure that we have for her here with her health, and that's what's keeping her from coming in. So you guys want to catch a good show and a good lesson. I think that's a good lesson that from our Take Health to Church show on Monday night. And then Tuesday, one of my ladies today described it very well. I had a lot of information that I was trying to push down into bite-sized chunks that we could get a hold of. And so Tuesday's show was very broad and a lot of building of a foundation that we could talk on. And then last night's show, I thought we did pretty good of kind of pulling it all together and really trying to work through some things. And I just left it right here. I got all my notes from where we were talking about last night, and to move us forward and to go with a new show tonight. Well, what was super interesting, and you know how the Lord works, he puts things in order and he puts them in timing. And, you know, I'll check I've got a certain group of guys that I follow on YouTube, and a certain guys and gals, and a certain group of doctors and stuff that are on Instagram and all that sort of. And I mention those guys all the time. I try to give shout outs to them because I think their content is just great. And Andrew Huberman is one of those guys. And Andrew, in case you don't know who that is, he's a neuroscientist, a tenured professor of neurobiology and ophthalmology at Stanford School of Medicine. And he's got one of the hottest podcast YouTube channels on the internet. And he does a super good job of bringing us information. And so we listened to him not too long ago when we had Charles Zucker on the show, when he had Charles Zucker on the show. And then we played a clip from that show on our show to talk about why we eat sugar and what we're doing and all that sort of thing. Well, I woke up this morning and it said, "Hey, check out our new show." And he's got I'm not gonna pronounce this properly, probably, but I'll give it my best shot. Dr. Diego Borregas. He is a PhD professor of medicine and neurobiology at Duke University. And the title of their talk is "The Science of Your Gut Sense," SENSE, and the gut-brain axis. And so it was really cool. And I've only gotten through about an hour and 46 minutes of it since this morning. And so then it's like a 2-hour and something podcast. And so I can't wait to get tonight and then in the morning have another shot at it and see if I can get most of it broken down with the information that Dr. Diego, I'm going to call him, brings to us on that show. So, but it's right exactly in line with what we've been talking about this week. And trying to answer a question, trying to answer a request, really, of, hey, Doc, would you talk about, and let me just make sure I get it right, because this is the request that was asked of me. Would you do a show at some point on how important your diet and sugar consumption and all those things are for people that are battling with brain problems? Example, anxiety, depression, post-traumatic stress, that type of deal. So that's what this whole week has been about. That we've really tried to get into it and break it down. And I am so proud. It was so cute today. Last night I said, I have all these ideas through the day, and I just need to get a notebook in my adjustment room so that I can write them down as I'm going through the day. And here you go. One of our beautiful listeners who listens to the show on a regular basis, who came in and brought me she came in today at the office and brought me a notebook. And so a little notepad right here. So thank you very much. You know who you are. I appreciate you. That was super cute. And we've already got notes on that, dude. So I appreciate you for bringing that in. So that's what we're going to do. We're going to try to bring it to you tonight. We're going to try to just keep going with the same theme and take that big old chunk of information that we were working with on Tuesday, that we did a better job with last night, and we're just going to carry it right through tonight and just keep it going. So let's get to it. I don't have an article for you or any sort of research, because I just thought I'd just start and get going and try to get as much of this covered. I know how quickly these nights get away from us, and I'll see if I can just keep it going, right? So let's pick up where we were last night, and let's make sure that we're trying to really understand what we're trying to define tonight, and or what it is we're after. Okay, so the question is how important your diet and sugar consumption and all those things are for people who are battling anxiety, depression, post-traumatic stress, right? So we tried to lay the foundation of, we tried to talk about some basic things over the last two nights. Number one, we tried to talk about motivation and what drives motivation. And we talked about the neurotransmitter, the chemical, if you would like, of dopamine. And we've talked about where that is created in the ventral tegmental area, the VTA, a little nucleus of the brain, right? And where it fires to, the nucleus accumbens, and another little nucleus in the brain. So we talked about the foundational idea that in order for us to be motivated, in order for us to feel like we have any motivation to get anything done, that's what dopamine does for us. When we get dopamine releases, it fires and it gives us the motivation, okay? But we also talked about what happens when we become resistant to a neurochemical. What happens, like you've heard of type 2 diabetes is insulin resistance, right? Well, what does that mean? And we tried to lay the foundation of the idea that it's almost, to a certain extent, it's almost to it's illustrated very well in the idea of the boy who cried wolf. If you know that story about the boy who cried wolf, that's kind of what insulin resistance is, in a way. It's not a very medical, scientific way of describing it. But if you cry wolf over and over and over again, pretty soon, and if you guys that story, that pretty soon the group around you is not going to respond to you, because all you do all the time is cry wolf. Like you're there's threat. Like, hey, there's a tornado coming. Everybody quick, there's a tornado coming. Oh, false alarm. There's a tornado coming. Oh, false alarm. There's a tornado coming. And then pretty soon everybody's like, dude, don't pay any attention to that guy. He's just running off at the mouth, right? Well, that's, in a way, in a different kind of mechanism. That's what resistance is all about inside the body. If we release insulin too much, if we release too much insulin, we will become insulin resistant. How do we release insulin? We spike our blood sugar. We raise our blood sugar, so we raise our insulin. Our insulin has to dock with the insulin receptor on the cell wall, mostly on fat cells and muscle cells, but we're docking with the receptor, and if we dock with that receptor and dock with that receptor and dock with that receptor over and over and over again, that cell gets tired of being treated that way, and it either there's damage to the receptor, or the receptor basically just gets taken off the wall. Now we cannot respond to insulin like we're supposed to. Last night we talked about leptin. And leptin is a chemical released by fat cells that tells the brain that you're full. But if you fire that leptin all the time, you start to become leptin resistant. So now your brain is not responding to your cells when they're full, and now you just keep going and keep going and keep going, right? Well, another way that you can become resistant is you can become dopamine resistant. Those cells in the nucleus accumbens, that place where we actually consummate the pleasure. So it's a word it's often used to express it. We understand it from sex, right? Everybody understands it from that standpoint. There's dopamine that drives us towards the sex, but it's not the dopamine that is at the consummation of the pleasure, right? And a lot of times the end reward is not quite as thrilling as the chase was. The chase is what really was rewarding about the whole thing. It's like it's the I got to go get the cookie situation. I gotta. That's why stores, the billboard on the side of the highway that leads you to the Dairy Queen. That anticipation, that's driving your dopamine. And that dopamine is if you hit those cells with it too much, you get too much dopamine, then what you will end up with is you will become dopamine resistant, which means in order to get the same amount of motivation, you've got to push harder. You got to get a harder hit. You got to keep it going, right? And we talked a little bit about on Tuesday night, a little bit about how whether or not like the cell, like what keeps dopamine going? What do certain medicines do? Like certain medicines will block the absorption of the dopamine, so you can't take it up. You can't take it up. So now the dopamine stays in the synapse between the two cells, which gives you that motivation for a longer period of time. Or there's different kind of medications that try to dissolve or not dissolve dopamine, or the other chemicals. I'm trying not to get too complicated, but the other chemicals that are involved in the whole process, right? So those are the foundational things that we talked about last night. So let's go back again, and let's talk about, because I want to answer the question. I want to get to the end result of the whole thing, but let's go back and talk about the bell curve. And I hope you guys that are listening on the radio can actually draw a bell curve. You guys know what a bell curve looks like. If you're drawing it, just draw a graph. Just draw a big L. Make your graph. Start from the bottom left corner, and then just go up and down, make a big bell curve right there. You guys know what that means. So there's a sweet spot in the middle of the bell curve. There's a good amount of dopamine that we need to have in order to function. If we're low on it, we don't have any motivation. If we're high on it, then we get irritable. So we want to make sure that we stay in the middle. And so we want to make sure that we're controlling the amount of dopamine we have. But the one thing that I've learned through all of this education that I've been getting over the last several years is that controlling external levels of dopamine, controlling dopamine through external sources is very difficult to stay in the middle of the bell curve. It's really hard to... We used the thermostat idea over the last 2 nights. Y'all ever been in a building? I think we used to do it I think in a building at Texas Tech, maybe when I was going to school at Tech. The air conditioner was controlled by the central office, by some building, maybe in the school district or like something outside that the central office would have been in a school district, but there was something like the thermostat. We didn't have a thermostat in the building we were in. It was being controlled in another place. What they decided to do, I'm sure it had to do with cost saving efforts, is they decided they were going to build this building, but they weren't going to let the people in this building control the thermostat. The thermostat was going to be controlled by the people in the main office somewhere in the central location, so that they could control whether or not, they could control the cost by keeping the thermostat turned up high, so we wouldn't have to run the air conditioner all the time. So it was always hot in there. Yeah, I mean, you know what I mean? Like if my thermostat inside my building is being controlled by someone over at Texas Tech, which is across town, and those guys are trying to regulate what it's like inside of me, the chances that I'm comfortable inside my own self, inside my own building, is going to be really low, because I've got some sort of external source that's trying to control my motivation. I got some sort of external source that's trying to control my environment. And what I've discovered over these last couple of years is that we have an internal system of control of dopamine. Because number one, if we just go back far enough, if we would just take ourselves as human beings out of this world that we live in today, and take ourselves just, I always say a couple thousand years, just go back 1,000 years. Like, take us back. It's 2024. Take us back to 1024. Like, what was it like in Lubbock, Texas in 1024? Who was here? What was going on? Well, there was no electricity. There weren't any buildings. There was no roads. There were no roads. It was really, really natural. It was just dirt and grass and animals, and maybe there's some other people running around out here, right? Okay. What in that environment would control? What would I do if I was trying to get some dopamine out of that environment, right? First thing I would do is I would have tons of dopamine receptors on my cell walls. I would have tons of it. So if I just had the slightest hint of dopamine release from the ventral tegmental area, it would motivate me to get going. I wouldn't need hardly any dopamine at all. There would be very, very little, because I would have so many receptors. It's like if you guys are familiar with West Texas at all, it's like the ranches. It's like the land that's Debbie and Zay, they've got a ranch over there. It's like the land on east of Post. Like if you go south out of Lubbock, southeast, and you get to Post, and you just turn straight east, that land over there in that area is so responding to just a little bit of water. It's kind of like eastern New Mexico, where I grew up. If you just give it a little bit of water, it just explodes. It just turns green like you wouldn't believe. It's not like the South. It's not like East Texas or anywhere from Dallas all the way to Florida. that has all that water all the time, that's that kind of green. This land out here, it doesn't get much moisture. So those plants have developed over the years to just a little bit of rain. You just give that land a little bit of rain, and all of a sudden it just turns green. Why? Because the natural environment to the plant is that, dude, we may not get very much water this year, so we kind of need to be able to respond to it. Well, that would be the same thing for us in our own natural bodies if we were living here 1,000 years ago. What are our dopamine things? Cocaine? Okay, maybe we might find some peyote or whatever it's called, right? I know that's probably not the right word, but whatever. You might find some weed somewhere that might make you get a little crazy. A loco weed or whatever we called it in on the ranches in in eastern New Mexico. There may be something in there might be a little bit of that, but what do we have here? We have cocaine, we have methamphetamines, we have alcohol, we have cigarettes, we have pornography, we have roller coasters and fast cars, and now we got cell phones and Instagram and YouTube and Twitter and all the things that we look at all the time, right? Every one of us. It doesn't matter how many times I talk to my patients about leaving their cell phones in the car. Nobody does it. I've stopped. I've decided this week just to stop saying that. There's no sense in saying it because you're just talking to the wind. We're so far past it to think that you could actually go into a doctor's office and leave your cell phone in your car. Don't even bring it in. And everybody say, well, I have to bring it in because I might have a phone call, or I might have a thing, or I might miss a deal, or somebody needs to get a hold of me, or I need to do some work or whatever. Yep. Just like it was in 1987, right? You went to the doctor. What'd you do? You read the little magazines that were sitting in the waiting room because there was nothing else to do because we didn't carry those things. We lived in a certain time where we didn't need them at all. And now we live in a time where we can't live without them because of the dopamine. That's just dopamine. That's the only reason I defend having my phone with me all the time. It's not because I need my phone. It's not because I'm going to miss something. Heaven forbid somebody had to wait 30 minutes to call me back. Heaven forbid there was 30 minutes where I didn't see what was going on, or 20 minutes, however long it takes to come in and get adjusted, right? Those are all those sources. And so what has happened to us? Those cells have become dopamine resistant. So we need more of it, and we need more of it, and we need more of it to respond, right? That's kind of what's happening to us. And so an external source that controls the middle of the bell curve is really hard to control. It's really hard to control. What we really would thrive on is we would thrive on an internal source of control. And when I say that, what do I mean by that? Well, that's what I got from the master and his emissary. That's what this means. That's what this up and to the right and over to the left means. It's the proper way. And when I was thinking about that this morning, it's like that up and to the right and over to the left is not a specific pathway. For all the neuroscientists and all the chiropractic friends and all the people that watch the show that are like, I don't know why he talks about that. It doesn't make any sense. It's not the way it works. No, it's not the way that any specific thing works. And no, the right hemisphere is not the only hemisphere that works off of adrenaline. The left hemisphere does as well. But the right hemisphere has a little bit more affinity for adrenaline than the left hemisphere. And the left hemisphere has a little bit more affinity for dopamine than the right hemisphere. And if you were to add up all the sum total of all the energy that's traveling into the brain, and you were to look at a sum total package of how it went from how the river flowed through the nervous system, what you would find out is we're not going to go one step further until we've decided that there's no threat in here. We're not going to get to the left side until we've eliminated that threat. And that pathway, if it's flowing properly, it controls our motivation. It has an internal, innate, God-given, which means that's what innate means. It has an internal, innate system that guides our dopamine levels to the motivation that we need to live. That's something that's inside of us. I've never been more motivated in my entire life, and I haven't had sugar in 2 years and 3 months. Right? I haven't had bread in 2 years and 3 months on Tuesday. It's 2 years and 3 months since I had a slice of pizza, and I've never been more motivated in my entire life. I've never been more excited about my job. I've never been more excited about my life. I've never been more in love with my wife. Whew, you're lucky on that one because we got a break. Sorry. we almost got out of control right there. So hang on. We're going to take a break. That's good timing right there. We're going to take a break and we'll be right back. This is Life with Jason Clemmons, DC. I know all you guys on social media cannot hear what's in my head what's from the radio, but I got a live radio show going on right here in the middle of this show, and so all of a sudden the timer just comes up and then it starts playing my music to my show in my ear to give me a 30-second moment. It gives me 30 seconds that says, hey, we're going to take a break, and it starts playing that music. And I know it's very awkward for you guys that are watching on social media because I know you don't get that. You're not getting it, but that's what's happening. That's why we go to break. Okay, we're talking about motivation. We're talking about internal motivation is the best way, right? So the question that was asked to me, what does diet have to do with anxiety? If I'm dealing with anxiety, depression, if I'm dealing with post-traumatic stress, etc., how important is diet and sugar to the way that I'm functioning? Okay, let's look at that. Let's look at that just on the bell curve, and let's just kind of let's start to understand that. Let's say that this is function, right? Let's say that this bell curve that we're looking at over here is the way that we're functioning. It's low function and it's overactive. Irritability. It's too much. It's too much. We know people like that. We've been that way before. We get too hyped up. We get too hyped up. We get too hyped up. It's like we're going to push ourselves right through the stop sign. We're going to push ourselves right over the edge. We're going to drive ourselves right through the middle of everything. We're uncontrollable. And then anybody gets in our way, we just get bitchy with them and just like, nope, get out of my way. I'm going. I got too much to do. You guys are a bunch of losers is what y'all are. Y'all just a bunch of losers. Get out of my way. I ain't got nothing to do with you. Pow, 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 pow. Drive my way right through it, right? Because this whole left hemisphere is very cocky and arrogant. Let me get us back on. Hang on. Okay, we're back. This is Life with Jason Clemmons, DC. We're breaking down the sugar and the anxiety, right? Okay. The left hemisphere is very cocky and arrogant. And if we're going to load that dude up with dopamine, we're just going to keep driving the dopamine and keep driving the dopamine and keep driving the dopamine up. We're going to get more cocky and arrogant. We're going to think that we know everything there is to know about everything, and we're just going to ignore this whole right hemisphere, which is the wise master. You know what's so funny? I got my neurofeedback book. I got a textbook of neurofeedback that since we started doing the neurofeedback, and I was reading through that this week, and reading through that textbook. It says the left hemisphere is the dominant hemisphere. I was like, oh my gosh. Like, okay, no, that's not true. That's old stuff. That is not, and it's controversial, and there'll be people fuss about it then and the whole thing. But the left hemisphere is not the dominant hemisphere. The left hemisphere is the cocky, arrogant, thinks it knows it all, get the work done hemisphere, and the right hemisphere is the one that's looking out for things, that puts the whole meaning to life. It's the one that has empathy for other people. It's this. It's the side. It's the side that gives you wisdom. It's the side that gives you wisdom. Okay, but it's also on the lookout for things. So, what did I learn this morning from Dr. Diego, right, at Duke University? I listened to that. And if you listen to about minute 58, if you want to go to that podcast at Andrew Huberman at Huberman Labs and listen to that, Dr. Diego Borges, Bohorquez, Borges. If you go listen to Dr. Diego, in about minute 58, they'll start to explain what he actually found and termed, coined, named are cells in our body that he called neuropods. And what he discovered is that, goes right on along with what Charles Zucker was talking about, is this, and I'm just going to clear this off for just a second because I know you guys are tired of looking at this. But inside our body, we have different kinds of cells. Like you have nerve cells, you have muscle cells, you have in the lining of our vessels, in the lining of our blood vessels, in the lining of our intestines, and like coming through our stomach and through our intestines and our small intestine and all the way through, we have epithelial cells. And so it makes a tube, and they're kind of columnar epithelial cells, and they're all just kind of hooked together. I didn't draw that one very good, but it's just kind of there's different kinds of epithelial cells, and they're that's a cell and a cell. That's leaky gut right there, by the way. And then there's a cell, and it's just kind of hooked together. And just for simplicity, I'll just draw it this way. And it actually works, and it goes like, that's not very good, but it kind of goes like that. And then all these columnar epithelium are all along the edge of it like this, and these are microvilli that come out, and then, so this is the lumen. This is where food travels through the middle of your intestine, and these little epithelium cells, where it travels through. Maybe it looks a little bit more like that, and now you've got all these little cells along the edge that are called epithelial cells. And then you've got the blood supply that's coming like that. And you got the blood supply that's coming down at the bottom. It's coming like that. Okay, now food is going to travel this way. And you've got all kinds of bacteria inside your gut, and you got all of these bacteria, and these bacteria are eating down this food, and then the bacteria, or there's like this whole layer that goes over the top of these epithelial cells, and then the food is going to get eaten up by the little bacteria that are all in here. And that's your microbiome, and then that eats the food, and then it presents it to the epithelial cell, and then the epithelial cell takes it through here, and then puts it in your bloodstream, and then now that's how we absorb our food. Okay? Well, what Dr. Diego discovered is that some of these epithelial cells are built a little bit different. They actually have a little extension that comes out. They actually have like a little extension that comes out, and then it's got little hair-like particles all around it. And he calls that a neuropod. And that neuropod is actually connected. It's connected to the vagus nerve. And the vagus nerve is connected to the brain. And when we eat sugar, glucose, and the glucose is detected in the gut, especially in the small intestine. When the glucose is detected in the small intestine, that neuropod says, hey, I got glucose right here. Here it is, right there, bam. And it sends the signal through the vagus nerve to the brain. And what is the response of the brain? When this happens right here, what do you think happens inside the brain? The brain releases dopamine. And we love that. And it's motivating to us. And we want more of it. It's more motivating. What have we done? What did we just do? What did we just do to the bell-shaped curve? What did we do to our dopamine level when we ate sugar? We moved our dopamine level to the left, to the right. We pushed it to the right. Now, if we're over here on the left of the curve, it gives us a little motivation. If this is where we are right here, and we're on the left of the bell-shaped curve, and we need to get to the middle, and the dopamine is going to move us towards the right, it's going to give us a little motivation. So it's like, man, I just want just a little bit of sugar. I just want a piece of bread. That's all I want. I just want a piece of bread. I just want a cookie. I just want one cookie. That's it. That's what I want. Okay. There is a certain population of us who tend to be a little bit on the left side of that bell curve, that when we go search for glucose, it moves us to the middle, and then we're in this ideal, beautiful middle spot of the bell curve, and we function fantastic. It's just a little bit, okay? But if you add that little bit to a little bit of phone and a little bit of other stimulus and a little bit of alcohol and a little bit of cocaine and a little bit of this and a little bit of that and a little bit of sex and a little bit of pornography and a little bit of everything else, you're not on the left side of the bell curve. We've got so many things that's already got us over here on the right side. So we got so many things that are going to drive us even further, and now that cookie is not. So let me back up so I can say this as clear as I can think it, okay? For a person that's on the left side of the bell curve, eating a little bit of glucose is going to be good for the brain. It's good. Your brain actually does really well on glucose if the glucose stops in the middle of the bell curve. Your brain does not do good on glucose if the dopamine. I didn't say that right. Okay. If you get your dopamine levels to the middle of the bell curve, you do pretty well. You function really well if you stay in the middle. You've got plenty of motivation. You're not irritable. You're not lethargic. You're doing really great. You can keep moving, okay? If you're in the middle and you're doing really well, and then you add more dopamine because you got more glucose in your bloodstream and your vagus nerve fired into your brain and released the dopamine, not directly, there's some steps along the way, but the end result is that that's motivating. And what if you go to 59 minutes in that Huberman podcast, what he'll say is that the neuropod cells will fire in response to the glucose from the small intestine, which will fire into the brain below our level of awareness. It is below the conscious sweet taste of the ice cream. The sweet taste of the ice cream is on the tongue. That's what we are aware of. We are aware of the glucose, the sugar that's on the tongue. What we are not aware of is the epithelial cell that's firing through the vagus nerve, that's firing into the brain, that's firing the dopamine, which pushes the dopamine to the right side of the bell curve, which now increases the dopamine availability, which now decreases the dopamine receptors in the nucleus accumbens, which takes the pleasure out of life, which means in order to have the same amount of pleasure, we got to drive the dopamine harder, and we got to have more of the sugar and more of the sugar and more of the sugar. And the two Reese's cups, the one Reese's cups becomes the two, which the two becomes the four. Which, why do they make a king size Reese's cup? Why does the maker of Reese's cup make a king size Reese's cup option? What in the heck is wrong with the two Reese's cup option? Then what's wrong with the two Reese's cup option is that people don't want that because they've driven their dopamine so far to the right of the bell curve, and they've become so dopamine resistant that in order to have any pleasure in life, I got to eat the whole daggum bag of Reese's cups. Right? I was a little passionate, but I think it was on the money right there. It's below our level. It's below our level of consciousness. And what I mean by that is, tell me, you've been listening to me for a few minutes now. Tell me what's going on in your spleen. Do you have any idea? Do you have any idea if your osteoblast or osteoclast are actually firing right now in your femur? Are you breaking down bone, or are you building up bone? Are you making red blood cells right now? Have you felt that? Do you know anything about what's going on in your red blood cells? Can you tell me exactly how many heartbeats you've had in the last 15 minutes? Do you know whether or not you've sped your heart rate up or slowed your heart rate down? No. Why? Because first of all, you would die in a second if you had to be conscious of all of that stuff. 95% of brain function is below our conscious awareness. We're not thinking about our spleen. We're not thinking about our liver. We're not thinking about any of that. It's below our conscious awareness. But what is also below our conscious awareness is our absorption of our food in our gut. Now, something that is really cool, and I've been waiting on this. I've been waiting on this piece of information probably my whole life as an adult. This piece of information is going to blow your mind. Okay, everybody wants to fight about whether or not we should eat whole grains or whether or not we should eat carnivore or what we should do. Right? Here's what Dr. Diego taught me today. If I can, I wrote it on my handy dandy notebook here. Okay, what he found out, and it's cool. They've done some cool stuff in the lab. They used some jellyfish, and they've used the fluorescence of the jellyfish to figure out a way to get those into animals that they test. And now they can put that in the brain cell of an animal or the stomach cell of an animal or whatever. And now they can see the fluorescence and they light it up when that cell's functioning. And it's like super cool what they're doing, right? Okay. If an animal is eating a meal in the absence of protein, if the animal is eating a meal in the absence of protein, the animal will stop eating the meal. They'll just stop eating. If protein is low, the animal will ingest more food. They will eat more to make up for the deficiency. If they've got a little bit of protein, because we've got to have protein in order to function. Okay? So if an animal is eating, if whatever they're eating has a little bit of protein, then they will eat more because they're trying to get if they have to fill up their protein tank, but there's very little protein in this food, they'll just keep eating and keep eating and keep eating and keep eating until they try to get their protein tank full. If protein is low, the animal eats more to make up for it. Unless there is fiber. Unless there is fiber, and then neurons turn on a mechanism that cause microorganisms to synthesize essential amino acids that we would get if we ate meat. I'm going to say that again because that's deep as heck right there, and it's the first time you've ever heard it. I promise you. I promise you haven't heard this because today's the first time I've heard it, and I listen for stuff like this. Okay, if you're eating fiber and you have enough fiber in your diet, you have those neuropod cells, those epithelial lining cells, have the capacity to, through the nervous system, to activate the microorganisms that are inside our gut to make the amino acids that we get from eating meat. Because I've had this problem, and I keep the books in my office. I keep them right next to each other. If you guys ever know who Dr. Esselstyn is and who T. Colin Campbell are, those guys wrote the China study in Forks Over Knives, and they teamed up to do that. And they say, don't eat anything with a mother or a face. Don't eat anything with a mother or a face. And that they're like, that's what you need to do in order to stay healthy. And Dr. Esselstyn's son is a fireman in Austin, and he's a triathlete guy. He's a triathlete guy. He's buff. He's ripped. He's strong. He's got all kinds of muscles, and he doesn't eat meat of any kind. He doesn't eat anything that has a mother or a face. He's a forks over knives guy. Okay? How do you get all those muscles? How do you grow muscles from eating plants? The way that you grow muscles from eating plants is through that mechanism right there where the nervous system has the ability, if the fiber level is high enough, the nervous system has the ability to get the microorganisms inside the gut lining to start to synthesize the essential amino acids. The essential amino acids are the things that you have to eat. You have to have them, right? Well, you've got a mechanism inside you. You've got a microbiome inside of you that has the ability to do that. You've also, if you're not eating protein, and if you're not eating enough protein in your meal, if you don't have any protein in your meal, you just don't want to eat. If you have little bits of protein in your meal, you're going to consume way more calories than you would if you otherwise had adequate amounts of protein. If you eat more protein, you'll eat less calories. And if you eat more protein, you won't fire your insulin levels. And so you'll keep your blood sugar balanced, and you'll keep your protein where it's supposed to be, and you'll consume less calories. There's your carnivore diet. So now we got the carnivore people and the plant people can quit fussing with each other about who's the best, because they're both right. According to Dr. Diego, they're both right. And what does this have to do with anything? Like, where am I going with this? Well, what is a person that's dealing with anxiety? What is anxiety? What is happening? What is the mechanism? What do we talk about on Tuesday? Is anxiety. We talked about right side and left side, right? So if we have overactive, I don't know what color to use, overactive right side, it leads to anxiety. If we have underactive left side, it leads to depression, which are still two right hemisphere problems, right? If we have post-traumatic stress, now we got to split the brain from top to bottom, and we got to get the amygdala involved. We got to make that amygdala be involved. And now we've got the thalamus. We got the whole thalamus firing to the amygdala, firing to the cortex, amygdala shutting off. Bam, we don't have this mechanism going on. So what do we have? We have overactive lower right hemisphere problems, which gives us post-traumatic stress syndrome, PTSD. Right? Those are the things. So if we're dealing with these things, if we're dealing with all that right there, what do we want? What do we want to do with the way that we're firing our brain? What do we want to do with the right side to left side firing pattern? We want that to function properly. What do we want to do with our dopamine? The reason we got underactive left side, nothing stimulating it. We don't have anything stimulating that side, so it's depressing. How does a depressed person get out of being depressed other than killing themselves, which you absolutely don't want them to do, right? They're going to find something from an external source to fire into the left hemisphere to increase the dopamine. So we have a depressive person with an underactive. What is going on with all these other things? It's overactivity of that right brain. We've got too many tigers and lions that are fighting over there. What are we going to do to the bell curve? What are we going to do to the bell curve whenever we increase the glucose in the gut? We're going to fire the vagus nerve. We're going to fire into the brain, actually going to fire into the brain stem. There's some mechanisms that are going along there. Bam, here comes this whole thing. And what are we going to do? We're going to drive the dopamine over to the right side, and we're going to increase irritability. We're going to become more irritable, and it's going to drive us over that way. And we're already looking for tigers and lions in that direction, and it's not going to help us out and be stable. That's really crazy. It's I don't know, maybe it's really complicated, and maybe it's really simple, and maybe I've said it too many times, and maybe you guys are like, that's just enough. That's enough of it. But if you're trying to balance yourself and you're trying to get yourself, let me say this. That person that's going through all that stuff, that's trying to get that balanced, is going to have a hard time doing that by themselves. Because number one, logical behavior. Whenever we're stressed out, whenever we're dealing with this over here, and we're dealing with the anxiety and the depression, whenever we've got the stress response is going to decrease logical behavior. The stress response decreases logical behavior, so that you're going to have that person that's going to have a really hard time managing this problem by themselves. They need to be social. They need to move their feet. They need to get their eyes up. They need to try to control their diet by having some sort of high fiber or high protein diet that keeps them from getting out of control. That we want to control our calories, and that's what we probably should talk about that tomorrow night because what happens, just like not having enough protein in your diet causes you to eat more. Well, when you're dopamine resistant, it causes you to want more sugar, which causes you to increase your calories, which causes you to gain weight. Man, we've run out of time again tonight. I hope that was helpful. I hope we're getting somewhere this week. We'll probably follow it up again tomorrow night. If you got any comments, send them to me, 806-794-0400, or send me a comment through Facebook or social media, and see if we're answering the questions that you want to get answered. So thank you very much. We'll see you guys tomorrow night.